Hello everyone, Darren from DrayTek Australia and New Zealand. In today's webinar, I'll introduce you to DrayTek VPN solutions with a focus on LAN-to-LAN VPN tunnels. We'll start with some VPN basics where we'll look at what a VPN is and the types of VPN tunnels, how they work, VPN protocols and the configuration options in DrayTek routers. We'll also look at a solution DrayTek have available to help work around a common VPN issue and a central management package that also makes VPN configuration a simple drag and drop matter. So let's start by looking at what a VPN is. A virtual private network, otherwise known as a VPN, provides a secure and low-cost method for computers in different locations to communicate with each other across the internet, much the same as if they were on the same local area network. There's no need for a dedicated link between two sites, such as a cable or a Wi-Fi link, to allow the secure exchange of data. Computers can instead communicate across public networks or a wide area network in a manner that emulates the properties of a point-to-point private link. So a VPN is basically an extension of a private network using links spread across shared or public networks, such as the internet. The term VPN tunnel is used to describe the connection between a computer and the VPN server, or the connection between VPN servers. It's essentially a communication channel or a tunnel which protects data being transmitted within it from being accessed by anyone else. An analogy is a road tunnel for cars, wherein the concrete tunnel itself protects the cars driving through it from the water or earth above from crashing down. As you're probably aware, a lot of businesses choose to adopt virtual private networks to share their resources with employees and partners who are not based in the office at all times. I'm one of those myself. I'm based in Brisbane and I have access to shared drives in the Sydney office, and I even have an IP phone connected to the Sydney switchboard so we can transfer calls to and from each other, or I can talk to staff internally at their extensions. Organisations have also begun using VPNs to outsource their work, enabling them to lower internal staff costs while maintaining data security. That's also attractive to staff as well. Hey, the commute alone can easily add a couple of hours to your day, while also saving on commuting and parking costs, although my wife really hates it when I commute by bicycle down the internal stairs. It's important to emphasise that VPNs need to be secure. Data breaches not only lead to compensation and regulatory fines, but can leave lasting reputational damage. Using a VPN to avoid geo-blocking is a popular use for VPNs these days, but it's worth doing your research before picking a provider or package. Netflix and other streaming providers are onto this and tend to block connections from certain IP addresses, which they constantly monitor and update. The table shown here lists the number of VPN tunnels supported in each DrayTek router model. They start at 2 for the low-end routers, such as the Vigor 2765 series, and go up to 500 for the high-end Vigor 3912. The number of VPN tunnels a router supports will also often give you an idea of the size of the network or business that they're designed in mind for. So at the top of the table, you're looking at routers suited to small offices or homes, while at the bottom, you're getting into enterprise territory. We'll now look at the types of VPN tunnels. There are two main types of VPN tunnels available in DrayTek routers: LAN-to-LAN VPN tunnels and remote dial-in VPN tunnels. LAN-to-LAN VPN tunnels are used to connect two whole LANs to each other, for example a branch office or a home office, or someone working from home with multiple devices such as a laptop, tablet and IP phone connected to the head office for sharing resources. Through one VPN tunnel, many users or many devices can be connected to the same network over the internet. The users at the branch office can access servers and printers, for example, as if they are on the head office local network. In this mode, only one VPN connection is created and all staff at the branch office can access head office services through it. At the same time, head office staff can access branch office services. One requirement to be aware of is that two networks should not have the same subnet as shown in the example here. Router A, the headquarters on the left, is configured as the VPN server and has LAN IP subnets of 192.168.1.0 and 192.168.3.0. While Router B, the remote branch office, is configured as the VPN client and has a LAN IP subnet of 192.168.2.0, which is different from the Router A subnets. It doesn't stop with just one network connecting to another as well. Multiple local area networks can be connected, and later I'll show you how easily that can be achieved using DrayTek's ACS3 package. The second type of VPN is a remote dial-in VPN tunnel, also known as a host-to-gateway or host-to-LAN VPN. Here, a single user uses a VPN client, that's software, running on the computer to set up a VPN tunnel for secure communication with the head office network. The VPN client will use an IP address in the local subnet at the remote network. Note that each remote dial-in VPN tunnel created counts towards the total number of VPN tunnels supported in the router. For example, the VigorACS series routers support a maximum of 32 VPN tunnels. These can be 32 remote dial-in connections or a combination of dial-in connections and LAN-to-LAN VPN tunnels. Most VPN clients will work for a remote dial-in to a DrayTek router. The most common are the default VPN client built into Windows or DrayTek Smart VPN client, which is available as a free download for Windows, Mac devices and Android. You'll find the download link on our website at draytek.com.au as well as on the App Store and Google Play. We'll now look at how VPN tunnels work. This diagram shows a basic representation of how VPN tunneling works. In step 1, the data payload is sent from a PC to the destination network. In step 2, the sending router appends a tunneling header to the data packet. You could imagine it as a man putting the data into a locked briefcase handcuffed to his wrist. This encapsulated payload is sent across the internet to the destination router in step 3. The man travels to point B. And finally, the tunneling header is removed, that is, the briefcase is unlocked and opened by the destination router and the data payload is sent to its final destination in step 4. Some tunneling protocols not only encapsulate the data but can also encrypt it to further protect the confidentiality and integrity of the information. As shown in this diagram, the routers at each end of the VPN tunnel encrypt and decrypt the data as it is sent and received. There are 5 steps to establish a VPN tunnel between two routers. These are dialing, where the VPN client sends a request to the VPN server. Next step is peer authentication. Then we have VPN negotiation. This is where the VPN peers exchange messages about encryption and authentication. Both routers must agree on all parameters. After this, the VPN tunnel is established and the data is routed. This diagram shows the different stages in setting up an IPsec VPN tunnel. Understanding the different stages involved will help to troubleshoot IPsec VPN issues. Step 1, interesting traffic initiates the IPsec process. Interesting traffic is just the term for traffic that is to be encrypted over the VPN connection. So effectively what we're saying here is that host A has something it wants to send to host B in a secure way, so it initiates the VPN. Step 2, IKE Phase 1. IKE, or Internet Key Exchange, authenticates IPsec peers and negotiates IKE-SAs, or security associations, which sets things up for negotiating the next stage in Step 3. Step 3, IKE Phase 2. Here, IKE negotiates IPsec security association parameters and sets up matching security associations in the peers. Step 4, we have liftoff. Our IPsec tunnel is established and we have data transfer. Step 5 is just shutting the tunnel down again, which could either be intentional or maybe a problem with the internet connection at one or both ends, or maybe just a timeout due to inactivity. There are plenty of knowledge base articles and guides and YouTube videos that describe how IPsec works, so check out our knowledge base or the knowledge base at draytek.com, or even just Google around. Once you've done one using DrayTek routers, they're really not that hard. Now we have some idea of how VPN tunnels work, let's look at the different types of VPN protocols used in DrayTek routers. The most common VPN tunneling protocols are available in DrayTek routers, which includes those listed here. There is no additional licensing requirements to use these. OpenVPN was added from firmware version 3.9.0 in DrayOS routers. The latest addition is WireGuard, which has been added to the latest firmware for higher-end routers, such as the Vigor 2962 and Vigor 3912. WireGuard requires public and private keys to be generated, and these are exchanged between the VPN server and VPN client. More information is available in Knowledge Base Article 10691 if you'd like to learn more about it. I'll leave a link to that below. Security features for some of those VPN protocols are shown in this table. At the top, we have GRE, or Generic Routing Encapsulation, which is a basic protocol that offers no encryption or peer authentication. We use GRE where IP tunneling without privacy is required. It's simpler and thus faster. It's also used inside an IPsec VPN tunnel in DrayTek's VPN load balancing feature, which I'll explain more about later. PPTP adds a bit more security, requiring a username and password to authenticate, but it can also be encrypted as well. L2TP Layer 2 tunneling protocol offers a higher level of security than PPTP by adding an IPsec policy pre-shared key to authenticate. IPsec is the king of VPN security and is generally the way to go for business networks. It uses a pre-shared key with varying levels of encryption to authenticate. It generally requires a static or fixed IP address at both ends, but this can be worked around using DrayTek's aggressive mode IPsec VPN, which uses peer ID to authenticate the connection. SSL or Secure Sockets Layer VPN uses the same HTTPS protocol used by secure websites. This means as long as the router allows HTTPS traffic through, an SSL VPN should get through it as well. It's a great one for remote dial-in users using ISP-supplied gateways they have no idea how to configure, or the ISP may even have locked the interface. There's fewer restrictions for the data encrypted through SSL when compared with a traditional VPN. DrayTek's Smart VPN client that I mentioned earlier has an SSL VPN option. Also worth noting is that VPN performance is affected by the VPN protocol selected. The table here shows the VPN throughput for the Vigor2865 router. As we can see here, PPTP and SSL provide the slowest throughput, and IPsec has the best performance. OpenVPN has the worst performance due to its high overhead. Later model routers such as the Vigor2865 and Vigor2927 now include hardware acceleration for IPsec VPN connections. With hardware acceleration enabled, IPsec performance can reach 800 megabits per second, which is 2.8 times faster than when it is not being used. The first 16 IPsec VPN tunnels are handled by the hardware accelerator, with the remainder being handled by the CPU. When a VPN tunnel is disconnected and removed from the hardware accelerator, the next VPN tunnel being handled by the CPU is automatically moved to the hardware accelerator. We'll now look at the LAN-to-LAN VPN configuration options in DrayOS routers. For a new user, DrayTek provides a VPN client wizard and a VPN server wizard, which provide a step-by-step guide to set up LAN-to-LAN VPN tunnels. Using the VPN client wizard, you start by selecting the VPN mode and profile to use, then select the VPN protocol, then in the last step enter the VPN details. When finished, you'll get a page similar to this, giving a summary of the profile created. The VPN server wizard is similar, but in this case you can either create a LAN-to-LAN server profile or a VPN server for remote dial-in users to connect to. You start by selecting the VPN mode and profile to use, then select the allowed VPN protocols, and then finally the authentication settings. Once confirmed, all these details are saved to the profile. About halfway down the main menu, you'll find the VPN and remote access section where you can manually configure VPNs with a lot more detail and also check status. It pays to have a quick check of the remote access control submenu first to make sure the required VPN services are enabled in the router. In later firmware versions, the PPTP VPN service is disabled due to lower security of it. To set up LAN-to-LAN VPN tunnels, go to the LAN-to-LAN menu option as shown here. Each page has 32 profiles, so for routers supporting more than 32 VPN tunnels, you will have multiple configuration pages. Clicking on each index in the LAN-to-LAN profile page allows you to create a profile for each LAN-to-LAN VPN connection. Within each profile, there are 6 subgroups, which include common settings, dial-out settings, and dial-in settings, which will appear depending on the mode selected. We also have tunnel settings, 6in4 settings, and TCP/IP network settings. The Common Settings menu defines if the router should be the VPN server, client, or both. As a VPN client, how it should start the connection and when it should terminate the connection. As we can see, the call direction can be either dial out, dial in, or both. Idle timeout can also be selected. The default idle timeout value is 300 seconds. This is a time period the router will wait until it disconnects the VPN tunnel if no traffic is flowing. The ping to keep IPsec tunnel alive option in older firmware versions is now replaced with quality monitoring keep alive. The ping to keep alive was best used for diagnostic purposes and would cause the VPN tunnel to repeatedly drop and reconnect. This setting is independent of the DPD feature, that is dead peer detection, which in DrayOS models is enabled by default and can't be turned off. The DPD feature sends packets to the remote peer every 15 seconds. If it doesn't get a response 2 times in a row, the router will then disconnect the IPsec tunnel. There's an application note for this if you'd like more information. Just go to the knowledge base on DrayTek.com and search for DPD. Here we have the VPN dial-out mode to use when the router is the VPN client. There are a few settings required here. First, you need to specify the VPN type. IPsec is recommended since it provides the best security and performance. Next, enter the IP address or host name of the VPN server at the remote site. We also need to specify the encryption and authentication methods to use. A couple of points to note here are that this setting should match the settings of the VPN server, and it's recommended to use AES SH8256 for the best security and performance when using IPsec. An option available in the latest firmware is to establish the VPN tunnel according to a time schedule. For dial-out, always on mode is selected to provide a stable VPN connection that will not time out due to inactivity. In the IPsec dial-out settings, you'll notice main mode and aggressive modes. So how do you know which one to use? Well, where both VPN server and VPN client routers have static public IP addresses, use main mode. Main mode can also be used where the VPN client has a dynamic public IP address. Here, use the dynamic DNS for the peer VPN server IP address. When the VPN client router is behind NAT, such as when connected via 4G to the internet, use aggressive mode. This requires the use of the local ID or peer ID, which need to match on both the VPN server and VPN client. Where both the VPN server and VPN client routers are both behind NAT, use VPN Matcher, which we'll cover shortly. VPN dial-in allows the router to be the VPN server and accept dial-in VPN requests. For VPN dial-in, you'll need to select the dial-in option in the common settings section of the menu and also select the required allowed dial-in type to use. We can also set the idle timeout to be 0 so that the router will not drop the connection. We also need to specify the allowed VPN types and the remote ID for IPsec VPN connections. You need to specify the IP addresses for each end of the VPN tunnel when using main mode configuration, or use peer ID when one end doesn't have a static IP address. The third item to specify is the accepted policies. PPTP VPN just needs a username and password for authentication and is usually the quickest to set up. For IPsec, there are a lot more parameters that need to be entered. You'll also have to enter a pre-shared key for IKE authentication as well as the security method. There are a number of application notes available in the knowledge base at DrayTek.com covering various scenarios for creating VPN tunnels. Simply use the site's search feature if there's a particular aspect you'd like more information about. The next menu item is tunnel settings. This setting enables IPsec dial-out to use GRE over IPsec. This is mainly used in dual WAN and multi-WAN routers when setting up LAN-to-LAN load-balanced VPN connections between sites. The main thing here is that both ends must be in the same IP subnet for communication. That's the tunnel local IP and tunnel remote IP. The logical traffic setting is an optional function and ensures the data transmitted on the VPN tunnel is really sent out from both sides. A hacker can decipher IPsec encryption but will not be able to transmit data over the VPN. When using this setting, the remote peer will also need to enable it at their end. There is a new option in the latest firmware, and this is 6in4 settings. 6in4 is a tunneling protocol that encapsulates IPv6 packets on specially configured IPv4 links. This allows the transmission of IPv6 packets from the local site to the remote site via an IPv4 VPN tunnel. The last section is TCP/IP network settings. This allows you to enter the network details of the local and remote networks so traffic can be routed over the LAN-to-LAN VPN tunnel. The more remote subnet section allows the entry of additional remote networks. In routing mode, translate local network allows the same subnet to be used at each end of the VPN tunnel. The router translates the subnet to a virtual IP subnet. When NAT mode is selected, the option Change Default Route to this VPN tunnel forces traffic from the remote VPN connection to use this router as the gateway for internet connections. Here we have an example of the settings used for local networks and remote networks. The local network IP address of the router on the left will be the setting for the remote network IP for the router on the right. With more subnet setting, you can add more IP subnets of the remote network we need to access. This will be added to the routing table as shown in this diagram. Here we added the IP subnet 192.168.11.0 to the routing table. The option Create Phase 2 SA is required if IPsec is used and the VPN peer is not a DrayTek router. An application of using the more subnet setting is when VPN routers are connected to a central VPN server and branch offices need to see each other, as shown in this diagram. Here, each branch router will need to have the IP subnets of each of the other branch routers to allow communication between them. It's not necessary to enter the IP subnets of the branch routers into the more subnet table of the core router since they are already directly connected. For remote networks that use the same IP address space, DrayTek have added an IP translation feature which uses a virtual IP address to avoid routing conflicts. This feature is available for IPsec VPN tunnels. IP addresses that are not defined in the virtual IP mapping list will be blocked from the VPN tunnel. This option is available in TCP/IP network settings in the VPN profile. There are two translated types to choose: whole subnet or a specific IP address. Clicking on the virtual IP mapping button brings up a dialog box to specify the local IP address and the mapping virtual IP address. Once the VPN tunnels are established, the routing table is updated with a static route pointing to the remote network. The interface is shown as VPN in the column on the right. An option available in dual and multi-WAN routers is VPN trunk management. This allows configuring two VPN tunnels to the same destination and running them in either backup mode or load balance mode. With load balance mode, both VPN tunnels are active and load share the traffic over both links to achieve a higher traffic throughput between sites. If one drops out, the other VPN will keep running. In backup mode, if the primary WAN link goes down, then the other one will come up and keep the VPN online. Once the VPN tunnel is established, we can check the status in the VPN and remote access connection management menu page in the router as shown here. To summarise what's required for LAN-to-LAN VPN tunnels, for the VPN client, set the call direction to be dial out, configure the dial out settings and specify the remote network server LAN IP subnet. For the VPN server, set the call direction to dial in, then configure dial in settings and specify the remote network server LAN IP subnet. We'll now have a look at VPN Matcher. In some countries, local ISPs will only assign private IP addresses for the general user because there's not enough public IPv4 addresses available anymore, or the numbers are very limited. This happens in Australia as well, when most USB dongles will only give you a private IP address, starting with 192.x.x or 10.x.x. This creates a major issue for the creation of VPN tunnels, where the dial-in VPN server will need a public WAN IP address to be accessed. DrayTek's VPN Matcher service works to resolve this. When DrayTek VPN routers are registered with the same DrayTek VPN Matcher account, they can locate each other, allowing them to establish a secure end-to-end encrypted VPN tunnel between the two routers, even if the public IP is hidden behind NAT or is dynamic. To use it, you just need to register the routers involved with their MAC addresses and subnets on the VPN Matcher website, and the stun server will keep track of the routers whether they are behind NAT or not. It's designed for DrayTek devices, but also includes any PC using the Smart VPN client. A point to note is that VPN Matcher is limited to a maximum of 8 devices, but if you need to add more, just contact us at support and we can arrange for the limit to be increased. DrayTek will need the username that you're using for the VPN Matcher installation, since this is linked to the VPN Matcher ID. There are 4 steps to follow when setting up a LAN-to-LAN VPN using VPN Matcher. The first step is to register all your VPN Vigor routers to DrayTek VPN Matcher and copy the router list key. If you find the device registered to VPN Matcher is not online, try the stun detection button in VPN and remote access VPN Matcher setup. This will allow VPN Matcher to find your device. Now set up the VPN profile. In VPN and remote access, VPN Matcher setup of both VPN server and client, use the router list key to get the group device list in your account. Once the setup is complete, VPN Matcher will help exchange the connection information, including IP addresses and ports for both routers. With this information, the VPN tunnel can be established. Let's now look at our final topic, which is VPN management when using VigorACS 3. With VigorACS 3, there are different wizards that can be used to create and manage VPN tunnels. The first is using the manual drag and drop VPN wizard. If you have SD-WAN enabled, you have the option to use the Auto VPN wizard to create either hub and spoke VPN tunnels or a full mesh VPN network. Before we look at those SD-WAN VPN options, let's take a look at a simple way to create a single VPN between two routers using ACS 3. If you've ever manually created a VPN, you're going to love this. If you want to create a VPN tunnel between two routers, whether they're SD-WAN or non-SD-WAN routers, ACS 3 makes it dead easy. It's as simple as dragging a router to the right-hand pane, selecting an encryption type, and then drawing a line from it to the router you'd like to create a VPN to. ACS 3 then does everything for you automatically and pushes the configuration to the routers. Let's take a look at that. So we go to Configuration VPN and select the network containing the routers that we want to create a VPN between. Here's an SD-WAN network that we created earlier that we'll use, but this feature doesn't necessarily require an SD-WAN network. So here we see that we have three routers in that network. Let's create a VPN between the Vigor 2866 and 2865. So all we do is drag the 2866 from the left-hand pane over to the right near the 2865. Then select the type of VPN we want. We'll run with IPsec. Then just drag a line from the 2866 to the 2865. When I let go of the mouse, we get a confirmation box. And once I click on yes, it starts creating the VPN and pushing the configuration to the routers. Now, if we go to the 2865 details, we can see the 2865 and 2866 connected with an IPsec VPN. And that's all there is to it. Job done. Okay, moving on to the SD-WAN VPN types. The first one we'll look at is a mesh VPN. The mesh scenario is fairly complex and will need at least three routers. It'll create multiple tunnels across the routers, and it can change VPN links in case a tunnel drops out. The mesh scenario is the way to go for large organizations when there are several central sites and where redundancy is required to prevent any loss of communication among them. The SD-WAN Auto VPN wizard makes the process simple. Even if a subnet conflict occurs during the setup, ACS 3 can design and suggest LAN subnets for all devices to get around it. Let's take a look at that between three routers as a demonstration: a Vigor 2865, a 2866, and a 2927. Note that each router in this case will have a VPN connection to the other two routers. So we go to the monitoring menu and select VPN SD-WAN. Then click on Add VPN Tunnel, and then click on Show Details. So first up, we need to select a type of VPN, either hub and spoke or full mesh. So we select full mesh, and we're given the list of routers in our SD-WAN network. Here we can delete any routers that we don't want included. Clicking on Advanced Mode, you can select a particular WAN you want this to go through, or which one to use primarily. Then select the type of VPN. IPsec is the default, but there's also PPTP, L2TP, or SSL. If I click on those, we get other options as applicable, like choosing usernames and passwords. We'll leave this one on IPsec for this demo. Then we just click on Save and Set to CPEs, and away it goes. If we click on Show Details, we can see the progress as it pushes the configurations to the routers. Close that, and we're back onto the page we started at, and we can see the details of our Mesh VPN all up and running, including a display on Google Maps if we've set up the API. If you want more information about setting that up, I'll include a link below to part 2 of our ACS webinar series, which goes through it from around 4 minutes and 56 seconds. We also get live monitoring with a bunch of information about the SD-WAN VPN and each router in it down the bottom here, which we don't get using the single VPN drag and drop method. That includes the type of VPN, uptime, usage, latency, jitter, and packet loss, which are combined to form a MOS, that's a mean opinion score. We want to see something between 4.3 to 5 here, so that top line isn't doing too great, but ACS can be set up to automatically change WANs or find alternate routes in that event to ensure maximum VPN performance. Now if we go to the Configuration VPN menu and select our SD-WAN network, we can see the Mesh VPN we just created. We can see that each router has two green arrows branching to two other routers. Green means the VPNs are IPsec, incidentally. So the 2865 is an arrow to the 2866 and another to the 2927. And we see the same pattern for the 2866, one arrow to the 2865 and one to the 2927, and the same pattern for the 2927. Now, if something went wrong and you want to start over, or in this case, I want to use the same network and change it to a hub and spoke configuration in a moment, there's a quick and easy way to delete it. Just go back to the Monitoring VPN SD-WAN menu and click on Remove All VPN Tunnels. Confirm that and away it goes, pushing that information to the routers. And done. Okay, moving on to hub and spoke VPNs. The hub and spoke is the most used scenario for a corporate environment where there is a head office and multiple sub-offices. VigorACS3's Auto VPN will take care of the VPN tunnel creation. You just need to specify the hub router, select the spoke routers from the list, select an encryption type, and ACS3 does the rest. Let's take a look at that. So we go back to the monitoring menu and select VPN SD-WAN again, then click on Add VPN Tunnel, and then click on Show Details. This time we'll select Hub and Spoke. We then need to select our hub router. Clicking in the box beside Hub Devices displays a list of routers in our SD-WAN network. Let's select the 2927 LAC as our hub router. Then clicking on Advanced Mode, we can see our spoke routers, which are all the other routers in our SD-WAN network. Again, you can click the X at the right of any routers you don't want included. Then select which WAN you prefer. Then select the type of VPN. We'll leave it at IPsec once again. Then we just click on Save and Set to CPEs and off it goes. Again, if we click on Show Details, we can see the progress. Close that and we're back to the monitoring page where we can see our newly created hub and spoke VPN displayed on Google Maps, assuming we've set up the API for it. And down the bottom is all the live monitoring information about the hub and spoke VPN and each router in it, the same as we saw in the mesh VPN. Just to repeat, you can only get this level of monitoring and the MOS when you use the SD-WAN wizard to create a mesh or hub and spoke VPN. It's not an option for non-SD-WAN routers or if you use the single VPN drag and drop method. Oh, one more thing, if we go to the LAN-to-LAN profile and click on the newly created link, we can see all of the details including the tunnel type, encryption used, and IP address information and so on. Okay, so today we started by looking at what a VPN is, the types of VPN tunnels, and how they work. Then we looked at the different VPN protocols and DrayTek router VPN configuration options. We also looked at VPN Matcher, which is used when both VPN sites are behind NAT. And finally, we looked at how to create VPNs using ACS3 and the additional SD-WAN monitoring features available in Hub and Spoke and Mesh VPNs created using the SD-WAN VPN wizard for SD-WAN capable routers. Okay, that's all for now, but please stay tuned. If you have any questions, we'll be available in the live chat on the right of your screen for the next 5 minutes. For more information about DrayTek products, please check out our website at www.draytek.com.au or send us an email to sales@draytek.com.au or give us a call on 02 9838 8899. Please like and subscribe below, and if you'd like a notification anytime we put up a new video, please select all from the subscribe drop-down menu as well. Thanks and bye for now.